Let's learn chain rule. Chain rule comes into picture when you have a composite function. So composite function means, for example, if I write y equal to 3x plus 4, this is a normal function. But if I write this as a cube, this is a composite function because it is a function of a function. Okay. Now, why we say that? Because you can write this as u to the power of 3, where u is equal to 3x plus 4, right? So you can write this as a function of a function. So that's called a composite function. When you have a composite function, you will have to apply chain rule. Let's see how you will work with the chain rule. For example, if you have a question like y is equal to 2x plus 4 to the power of 3. Okay. When you need to differentiate this one, what you should do is you just imagine this as a single one, like for example x or u. Maybe I can take another letter which is u. Okay, so just take like this, and if it is u to the power of 3, how will the differentiation be? It is like 3u square, right? So you differentiate this as 3 times 2x plus 4 to the power of 2. Okay, and then you differentiate this one. So differentiation of that is 2. Okay. So that's the method you use always. So you differentiate the outermost one first and then differentiate the inner one again. Okay. So one rule what I say to everyone is, for example, if I have 3x plus 4 to the power of 5. Okay. dy by dx is equal to, how we differentiate? It is like 5 into 3x plus 4 to the power of 4. So it's the first level of differentiation. And I will ask them to check whether this is x. Okay, it is not x. Okay, for example, let me just put it here. If it is x to the power of 5, dy over dx is equal to 5x to the power of 4. In this case, it is x. In our question, it is 3x plus 4. It is not x, it is 3x plus 4. So anything other than the x, you have to differentiate. So it is differentiate is 3. Okay, then you can simplify this as 15, 3x plus 4 to the power of 4. Okay, so anything other than x, you differentiate it again. That is my rule. Okay, anything other than x, you differentiate. Okay, let's do another question here. Y is equal to 2x square minus 1 to the power of 4. Okay, so dy over dx will be equal to 4 times 2x square minus 1 to the power of 3. Okay, and is this x? No, it's different than x. So differentiate it again, 4x. Then that will be equal to 16x, 2x square minus 1 to the power of 3. Okay, again another question, y is equal to square root of 4x square minus 2. So dy over dx is equal to, remember when there is a square root, we don't know how to differentiate. You have to write it in the form of indices. So it is over 1 over 2. So it is 1 over 2, 4x square minus 2, 1 over 2 minus 1 is minus 1 over 2 times 4x square minus 2, differentiation is 8x. Then this 2 and this 8 will get cancelled. So it is 4x times 4x square minus 2 to the power of minus 1 over 2. Okay. So this is how we differentiate using chain rule. Let's do some more questions so that we get practice. Y is equal to 2x square plus 3 to the power of 4. dy over dx is equal to 4 times 2x square plus 3 to the power of 3 times, this is x? No, differentiate it again. So it is like 4x. Then you have to simplify this, okay? 16x into 2x square plus 3 to the power of 3. Okay, another question. 1 minus 2x to the power of 5. So dy over dx is equal to 5, 1 minus 2x to the power of 4. Is this x? No. Differentiate it again, minus 2. So it is minus 10, 1 minus 2x to the power of 4. Okay. Now, okay. Now comes the combination of product and chain rule. Differentiate y is equal to 2x times 2x plus 5 to the power of 3. Okay, now remember, here there are two things. Since there is a multiplication here, this is a product rule, and since this is a composite function, you have to apply chain rule for that. So it's a little complicated. So let us try this. Dy by dx is equal to, first apply product rule. So product rule 2x times differentiation of the second term, which is 3 times 2x plus 5 to the power of 2. Is this over? No, this is not x. So differentiate that again, times 2. So this is where many people miss out on the differentiation, okay, on the question. Then plus second term, which is 2x plus 5 to the power of 3 times differentiation of the first 2. Then you can simplify this. So 2 into 3, 6, 6 into 2, 12, 12x times 2x plus 5 to the power of 2 plus 2x plus 5 to the power of 3, 2 times 2x plus 5 to the power of 3. You can leave it like this, okay? It's fine. It's you will get full marks for this. If you want to simplify, simplify. But if you leave it like this also, it is fine. Okay, let's do another question. X square minus 1 times 3x plus 2 to the power of 2. Why? So dy by dx is equal to x square minus 1 times 2. Differentiate this again, so it is like 2 times 3x plus 2 to the power of 1 times, this is x, no, differentiate it again, so it is 3 plus 3x plus 2 to the power of 2, differentiation of the first term, which is 2 x square minus 1, it is 2x, and that's it. Okay, then this is 3 into x square minus 1, sorry, 3 into 2, 6. 6 into x square minus 1 into 3x plus 2 plus 2x into 3x plus 2 the whole square. Again, you can simplify if you want, or you can just leave it like this. Now another question, y is equal to x square minus 3 to the power of 3. So dy over dx is equal to 3 times x square minus 3 to the power of 2. Is this x? No. So differentiate it again. So it is 2x. Then it is equal to 6x into x square minus 3 to the power of 2. Now let's move on to the combination of quotient rule and chain rule. Y is equal to 2x minus 1 the whole square over 3x plus 4. So this is, the numerator is a compound function and you will have to simplify this. So dy over dx is equal to, what is the quotient rule? First the denominator, so 3x plus 4 into differentiation of the numerator. So differentiation of this, so which is 2 times 2x minus 1 to the power of 1. And is this x? No. So differentiate it again. So 2. Okay. Minus numerator, which is like 2x minus 1 the whole square times differentiation of the denominator, which is 3x plus, sorry, it's just 3x. It's just 3 divided by 3x plus 4 the whole square. Now you can just simplify this, which is equal to 4 3x plus 4 times 2x minus 1 minus 3 2x minus 1 the whole square over 3x plus 4 the whole square. Okay, let me see if I have some more complicated ones. Yes, I do have. So y is equal to x over square root of x plus 1. So what all we use here? We have to use the quotient rule and we have to use the chain rule. Okay. So first you have to identify, whenever you see a question, you identify what you have to do and then you go ahead with that. So dy over dx is equal to denominator times the differentiation of the numerator minus numerator times differentiation of the denominator. Okay, before that, very, very important, x to the power of 1 over 2 plus 1. So that is the first step what I should have done. Okay, and differentiation of the denominator will be equal to 1 by 2 x to the power of minus 1 by 2 over different denominator, so square root of x plus 1 the whole square, so which is equal to square root of x plus 1 minus x over 2 times 1 by x, no, I can simplify it here itself, x times x, okay, let me just show it here, x times x to the power of minus 1 over 2. So this is 1, so you will get 1 over 2. So x to the power of 1 over 2 divided by square root of x plus 1 the whole square. that is equal to square root of x plus 1 minus square root of x over 2 divided by square root of x plus 1 the whole square. That's equal to, you can multiply it by 2, so 2 root x plus 2 minus root x over 2 times square root of x plus 1 the whole square, and 2 root x minus root x will be root x plus 2 over 2 times root x plus 1 the whole square. Okay, we will get the answer like this. So I think that's it for this one. Okay, maybe I'll just show one more question, which is 8 minus 2x square to the power of 2 over 3. Okay, then dy over dx is equal to 2 over 3, 8 minus 2x square to the power of 2 over 3 minus 1. And is this x? No, so you have to differentiate it again. So it is like minus 4x, and then it will be minus 8x over 3, 8 minus 2x square minus 1 over 3.